Hello everyone from the Novedge team. Welcome to today's webinar on VisualARQ 2.0 Flexible BIM for Rhino. The webinar will show the flexible BIM features VisualARQ adds to Rhino based on the upcoming 2.0 version, how VisualARQ streamlines workflow and improves architectural design process efficiency, how to model with 3D parametric architectural objects, how to create 2D documentation out of a 3D model, IFC import and export features, and integration with Grasshopper. Today's presenter, Francesc Salla, is an architect and the product manager of VisualARQ and lens design at Asuni. He has a wide experience in 3D architectural software, so as a professional user of the software is very demanding when it comes to improving VisualARQ, as you will see. Before we get going, here's an overview of what we do in Novedge. Novedge is one of the largest online stores for design software. We offer a huge assortment of software solutions that cater to virtually every designer's need. Come visit Novedge at novedge.com, where you can find VisualARQ and Rhino. And for more daily software news and promotions, pay a visit to the Novedge blog and follow us on Google+, Facebook, and Twitter. Coming up next week, a webinar on getting the most out of AutoCAD 2017. Last but not least, today's webinar is free and is being recorded. So if you want to watch this or any webinar episode in our collection, just head on over to Novedge's YouTube or Vimeo channels. Great, now that we got that out of the way, I will pass the screen to Francesc. Francesc, you're going to be the presenter at all effects.
Okay. There we go.
Fantastic. Showtime.
Hi everybody, thank you Barbara for the introduction. Today we'll see VisualARQ. I will show you an overview of VisualARQ based on the upcoming version 2.0 and explain what is this flexible BIM features that VisualARQ adds to Rhino. So first of all, VisualARQ is meant to make life easier to all the architects that work in Rhino. Okay, so it provides tools to generate models in 3D and also generate all the 2D documentation out of it. So VisualARQ is aimed at architects, of course, designers, professionals of the architecture and construction, engineers, interior architects, also Grasshopper users, as we will see later on with the integration of VisualARQ with Grasshopper, or artists of the architectural visualization as well. When we say that VisualARQ adds BIM features, we base this with the concept that everything comes from the 3D model. Everything is managed from the 3D model. Okay, so all the documentation drawings that are generated from the architectural model comes from the 3D geometry, and they are linked into it. So any change that is applied to the 3D model is repercuted to the documentation that is generated out of it. Also BIM, because VisualARQ provides a set of architectural objects that are parametric, and they have all the information inside the geometry. So in that way we know, for example, for a curtain wall, its height or its length, okay, or the style that this object is using. But also, being parametric means that we can change their parameters or their shapes very, very quickly. All right. Also, VisualARQ provides the option to change models within Rhino and other software products using this IFC file format, which is the standard file format for changing BIM models. So in that way, when we export, for example, this model we see in the left side that contains walls, windows, columns, beams, and we export that to IFC. When we open it in another piece of software like Revit, all these architectural objects are recognized as native objects in that software. Okay, and we can keep on continuing working with these objects in the other platform. I will show you later on how this works with some examples. And why flexible? So we understand flexible as the opposite of rigid, and flexible because VisualARQ integrates is totally integrated inside Rhino, which has wonderful capabilities to work with freeform geometry. And that makes it possible to create such projects like this one from random style architect. And also the visual objects can be created from NURBS. They support NURBS, so they can get very complex shapes. Flexible because when you work with Rhino geometry, sometimes you want to assign IFC information to the geometry in order to export it to IFC, for example, as a slab. So we have here some freeform polysurface, but with VisualARQ you have the option to tell this is a slab, and so when we export this geometry to IFC, other software, like in this case Revit, will recognize this object as a slab. Okay, and same for all the IFC categories that exist. Flexible because also VisualARQ is integrated in Grasshopper, as I mentioned. So on one hand, there is the VisualARQ Grasshopper components that let you create and work with the visual objects directly in Grasshopper. But on the other hand, and this is something that we'll show later because it's one of the main features of the new version 2.0, is the option to generate the visual objects from Grasshopper definitions. Okay, so we'll have plenty of freedom to create visual objects because they will be created from Grasshopper. As you may know, Rhino provides with all the drafting and CAD tools to finish shop drawings of a project of architecture. So tools are there, and VisualARQ just takes advantage of them as well. Also, for those that create section views, architectural viewings, so VisualARQ provides with some great tools for creating sections. Okay, vertical, horizontal sections, or assigning materials is just as easy as assigning materials to the geometry. In the same way, you assign materials to Rhino geometry, because VisualARQ supports the same render engines than Rhino. Okay, so we'll show you now the main features of the upcoming VisualARQ 2.0 version. Okay, and the main one is this option that I was mentioning about creating the visual object directly from Grasshopper definitions. Okay, so and this will be very useful for those who even doesn't know how to work Grasshopper, because everything will be seen inside the VisualARQ dialogs. We'll see an example of this integration later on. Secondly, we have integrated the option to print 3D models in vector output. Okay, that means that you will be able to set in each view, in each detailed viewport, for example, a 3D model in perspective, top viewport, section view, okay, and you will be able to print that directly in vector output in good quality. So there will be no need anymore to generate make 2Ds or plan or section views, because that will be a real-time render, real-time vector output printing. Next, we have added also the option to add new parameters, custom parameters, that later on you will be able to list. For example, you will create a parameter like the price or the fire resistance or manufacturer, and you will be able to assign this information to each object, not only visual objects, but also Rhino geometry. Also, we have added more flexibility to do Boolean operations with visual objects, because this is something that only was available on walls, but now it will be available for the rest of the visual objects. You will be able to do addition and subtraction without losing the parametric properties of visual objects. Also, we have added a couple of new objects, which are the furniture and the element object, that have the advantage that they can have two different representations when they are shown in 3D or in plan views. Okay. Of course, the furniture object is aimed at furniture elements, and the element object is aimed to any other object. Could be a tree, could be a street light, could be a human figure, anything else. Okay. Also, we have added the section manager. So for those who already know a little bit VisualARQ, you know that we have the level manager to work at different levels, and we have added also the same, but for managing sections. I will show you later how this works. And more stuff we have added in the new version is more enhancements in relation of the IFC import and export. We now export colors or materials. We will support external references, and Groups will calculate the intersections among them. And we have also added the option to calculate the intersections of beams, as well as controlling the beam cut planes at ends. Some development information. We develop VisualARQ according to the user feedback and requests, so feel free to let us know your thoughts or your suggestions. We'll be very, very pleased to consider them for the future development. There are commercial and educational licenses available. Just let you know that educational licenses have the same policy as Rhino educational licenses, so they can be used for professional purposes even after the studies, after graduation. Okay, and there is a evaluation version for 30 days available in the website. But if you need more time to test the version, just write me to any of these emails, and I will be very glad to provide you with an extension of the evaluation period. Okay, good. Now let's take a look at VisualARQ Live. Okay, I will show a very basic overview of how VisualARQ works, and later on we will see more of the new features that we have introduced. And I would like to show you just very quickly how to model a simple project. Okay, so first of all, I introduce you to VisualARQ toolbars. So on one hand, we have the set of architectural objects. Okay. On the other hand, there are some commands to generate the documentation. And finally, there are some other commands to make this process of modeling architecture inside Rhino easier and faster. So first of all, I'd like to show you the level manager that I was mentioning. Let's put it there, which lets you work at different levels. So basically, here we have a building with 2 levels. And each level has a construction plane at specific elevation. So you can change the position of this construction plane just by clicking on that icon here. So anything we draw now on that level will be created in that elevation, while if we change the position of this construction plane, now everything is created on that level. This is very useful because you change the position of the construction plane very, very often. And this is a really useful shortcut for this. Also, the level manager lets you show and hide levels, as if we had, for example, a clipping plane at the elevation of that level. If we see this from the right viewport, we not only see the reference marks indicating the elevation of each level, but this is like we're activating a clipping plane on that level that hides everything that is above. And in the same way, we can hide everything beneath the level elevation. And when we hide, for example, one level and we activate the cut plane of a level, this clipping plane moves to that distance, a distance that is indicated by this value here, the clipping plane head. That is usually the distance from which we usually see the doors and windows in cut planes, in plan views. Okay. So we'll show you that later on. The way to work with VisualARQ objects is very simple. So you run, for example, a wall command, which shows a list of wall styles. Each style determines the 2D representation of this wall, but also the number of layers it has. And then there are some insertion options. We just insert these walls as if you were drawing lines. Okay. And you can see already that the intersections are solved. So we can insert now a door. Again, we get a list of door styles. We select some insertion options, for example, the dimensions of the profile, and insert the door in the wall which snaps into it. So we can place the door outside, which floats in there, but as soon as it detects a wall, it snaps into it and generates the opening. Okay. And when we see these walls and doors from the top viewport, if we activate the level -1 and activate the cut plane, then is when we see this 2D representation of these elements. As you can see, all the intersections are solved. Also, we can edit these objects through control points. In a similar way, we would edit lines or surfaces, and we can, for example, stretch the corner of 2 walls by this control point, or stretch it in one direction, or change the height using these extension arrows. Okay. In case of the door, I can also change the opening side using these control points. But also, we can change the parameters of these walls from the properties panel. So here, when we have some objects selected, we can change, for example, all the common parameters that these walls have. For example, we can change the style, okay? Or we can change the head. So a common head for all three walls. And the same for the doors, just in case. Okay? And finally, if we wanted to create new styles, so we have to do just right click on the wall icon, and this works in the same way for the rest of the objects. Here we see the list of the existing styles in this document. For example, we can expand any of these styles and take a look at the layer. Here from the right side of the dialog, change the thickness of this layer, edit the construction details, or edit also the attribute information. For example, the layer, where it goes, the material, projection attributes, and also section attributes. If you need to create new styles, you can just run this wall style wizard and follow the steps of this wizard. So for example, let's create a 3-layer count style. We define some name and thickness for each layer. Just choose the default values. And when we are done, this new style appears here in the list. And now we can edit further this style. For example, we can change to the representation of this wall style. Okay, let's assign some hatch pattern, select hatch pattern for the representation in section. Also, we can change the thickness. So all these styles can be edited at any time. And of course, you can create your own library of objects, export them in order to be used in other documents or share with other people. Okay, now that we are done, let's change the style of this wall and see how it looks like. Okay, here it is. Fine. So now that we know how to work with different levels to insert walls, doors, and basic objects, now let's create this project, this simple project. So first, we're going to run the wall command, but in this case, we'll use the from curves option. So I have already here some guidelines, and I need just to choose the style and also the curves that I want to convert into walls. Okay, here we go. And we'll repeat the same for these inner curves. Okay, now I will choose this other style. And that's it. Also, we can select all the walls that we are interested, and change their properties. For example, we can change the alignment of these walls. So I just noticed that I draw these walls in the wrong alignment, so we can come here to the wall properties, and change the alignment to the right. Okay, there we go. So now let's hide the layer where I have these guidelines, and now we can create some slabs. So I'm gonna turn the layer on where the slabs curves are, and run the slab command. So this command can be created straight away in the model. So let's make sure we have the construction plane at level 0, and just draw the line, draw the slab here. Okay, and we can do the same for the slab we have down there. Okay, actually, I'm gonna create it in the full size. But for those cases that we have no rectangular slabs, we can run the slab from curves command, which works in the same way. Okay, and well, slabs are ruled also by styles. You can define different layers for each slab style, but in this case, we're going to change the thickness of this slab by object. Okay, so the thickness can be defined by style, but also individually by each slab object in the model. Okay, let me put this dark there, so it will be easier, and get rid of these two tones. Now, let's create an opening here in this slab. Since in the new version we have the option to subtract solids, this could be achieved by doing a Boolean operation with an auxiliary solid. But in this case, we'll use this command to subtract a boundary from a slab. So select this slab, now select this curve, and the opening is created in here. Okay, now we can insert, for example, a stair. So we run the stair command, we select one style, and we insert the stair in the model. As you can see, this stair has too many steps, so we can change their parameters from their properties panel. In the same way as you can edit all the other objects. So instead of 25, let's put 16. More reasonable number. And also, we can select the slab. Let's hide the cursor of the slab. And we can activate also the control points to change the limits of this opening. Okay, so we'll move this from here to there. And also we can change the width of the stair from the properties. So as you can see, it's very easy and simple to change the parameters of the visual objects once they are created. Otherwise, using Rhino geometry would take a long time. Also, in this case, for example, it's very useful, this icon here, this rule icon, to measure the distance we want to take for, in this case, the width of the stair. Okay, just as a tip. All right, now let's insert some railings to this model. So we'll activate the railing layer, and well, we'll run the railing command. We select one style. We make sure we're working now in the level 0, and just insert railing here. Okay, and we'll do the same for the railing that is in this balcony. So we have already a curve here. So in this case, we're going to create a railing from a curve. So we'll choose the from curves option in the command line, and just change the alignment in this case. Okay. And here we go. So it seems like I picked the wrong alignment, so no problem. I can come here to the railing properties and change it again, get back to the right. Okay. Let's change the display mode. Let's choose this shadow simulation, which is a custom style that I created. I see that I choose maybe these walls are too thick, so let me change the style. Okay, I'm going to choose these thinner ones. And also, since I see there is no space here, let's move this here and leave some more space. So we'll also move using the grid points, and I will stretch this wall back to this position. Okay, so now let's insert the openings in this model. So let's back to the ground floor. And here I realize that also these walls are too thick, so let's change very quickly the style for this thinner one. And we can insert here a few doors. Okay, so as I showed before, we pick a point and define the opening side, and very easily we insert some doors in this project. Okay. There we go. We'll do the same for the first floor, for the ground floor. Just doing double click, we switch the view into the ground floor. Now again, we insert a door here. We can change maybe the style, the size of this door, and some other door here for this bathroom. Okay. Good. Now back to the perspective viewport. We're going to insert the windows of this facade. I have here already some guidelines for the openings. because I will show you a different way to insert openings. So instead of inserting straight away in the model, we'll use the from curves option this time. So first you choose the style you want to create, for example this glitter one, and then choose from curves option the command line, and now pick these curves to be well, use it for the windows of this shape. Okay, and the windows will be created on the exactly position of these curves. So since they don't intersect with the walls, the opening is not created. But as soon as I select them, so let's pick all these windows and put them next to the wall, they already detect the wall and generate the opening inside it. Okay. We'll do the same for the windows we have in this side. So run the window command again. I will choose this fix style again from curves. We can choose curves of any shape, as this one. Okay. And we insert. Well, I see this just was created in the wrong direction, so we need to review this later on. It really doesn't matter now. Okay, and we can do the same for the door. Run the door command. Select one style. Select from curves option. Pick this curve, and now finally move the door next to the wall. Okay. Here I have a guided door, but for this style, I will show you this integration of VisualARQ with Grasshopper. Okay, so let's take a look at this. Rather than creating a new style, a new door style for a guided door, that actually there is no option to define, for example, like horizontal folding door with double lid. In this case, we'll choose a Grasshopper definition that generates this door. So first, let me show you the definition. So here I open Grasshopper. I open this file that generates a guided door. Let's see. There it is. Okay. So here it is, the guided door with the sliders that control the shape of the door, for example, the width or the height. Okay, the rest of parameters, we can change the aperture. So this is the kind of door that it's not possible to be done now, well, in the current version of VisualARQ, and unless you create a block and you assign a block to the style. But blocks are not parametric, as you know, they are static geometry. Okay, we have some inputs on one hand, and we have some parameters as the output geometry on the other hand. So we save this model, we save this definition, we close Grasshopper. Now, back to the model. We will create a new style, so we open the door styles. And now, as you can see, there is the option to create a Grasshopper style. So we choose this option, we will browse and pick the file we have just saved, this character, and just follow the steps of this wizard. So first we have to define style name, also choose the units. Also there is the option to define like a profile different than the bounding box that generates the geometry. Okay, now we'll choose this one. And here there are the two geometry that the definition generates. We can define which ones we want to import. Okay, so we will just import two of them. And here there is the list of parameters that define the shape of this door, and we can define each one if they are editable by style or by object, or just hide them from the VisualARQ dialogs. For example, aperture, we'll leave it editable by object, as well as the opening height or the opening width. Okay, and in some other cases, for example, this slider, I will just hide it and will be editable by definition. So click next, finish, and now we have a guided door in the style dialog as any other VisualARQ object. So here in the list, we get the guided door, so we can insert it in the model. Okay, and when we select it, we can take a look at its parameters, and here we can see the parameters that we left editable by style, by object, okay, such as the aperture, okay, or the width. Right. Okay, as you can imagine, this integration of VisualARQ with Grasshopper that will allow us to have never-ending possibilities for new designs of parametric objects. Okay, and someone who doesn't know Grasshopper will take advantage of this definition, because everything just will work through the VisualARQ dialogues. All right, so maybe in this project there is missing a roof, so let's create it. Activate this layer where the roof guidelines are. There are also new features about the roof command in the new version. It will be possible to create them straight from. Let me first create a new level, okay, where we will place the building. This will be located at 6 meters elevation, okay, and I can run the roof command. And I can create the roof as if I was creating a rectangle. Okay, as you can see, the axis detects the longest size and orients into it. Okay, but I can still have the option. Let's get rid of this roof. We still have the option to create roof from boundary curves. So again, I run the roof command, and in this case, I would choose the from curves option in the command line and pick this curve. Okay, I need to define the axis for gable roofs, and that's it. Okay. Now we can move the position of this roof up and down, and we can extend the walls to that roof. So here under the wall command, there is a command to extend walls. So we select these walls. We pick a direction in the command line, so let's choose top. And finally, the entity where the walls extend to. And when this happens, when the extension is produced, the walls keep attached to the object they have been extended to. So now, if we change the position of the roof, as you can see, the walls update automatically. Great. Now let's hide this layer of the railings and roofs. We can hide this roof to see the inside of the model. We could actually also hide this level to see the inside of the model, or maybe just activate the cut plane of this one. I should select it first. Now, and let's insert here, for example, a furniture object. So this is something that we have added also in VisualARQ 2.0, as I was mentioning at the beginning. So here there is the option to insert a furniture object. By default, there is just one simple box, but before inserting that, we will create a new style. So we do right-click on that furniture element, and we'll create a new style. There are two options here. There is the option to create a standard furniture style, or also a style from Grasshopper that would work in a similar way as a door we saw before. First, let's take a look at this option. So this is a furniture element that can use a block for the 3D representation and also a block for the plan view representation. So let's import this. This button shows a shortcut of your PC, so you can choose any model you have in your PC. For example, here I can get one of the sofas of the Savannah 3D library, this one, for example, and now we already have a sofa that uses a block. Okay. Right now there is no 2D representation, so we'll see what happens. We run this furniture element. We choose this one. There are here some interesting insertion options, because we can choose, for example, the alignment of that object, okay, as well as the scale of it, and we pick a point and insert this object in the model. If we see this sofa from the top view, what we see is the projection of this object. Okay. And actually, we should activate the plan view of this level, and then well, the section just cuts through the sofa. But this is not what we want. Instead, we'll create a block, a 2D block, for a very easy representation of this sofa. Okay, let's move this around here. Also, I will rotate this because the original block is located in that position, so it's very important that the 2D block matches with the position of the original block, with the 3D block in this case, and also the insertion part. We can draw a few details. Okay, very simple, and have a very simple representation for this sofa. Okay. Now, once this is done, we create a block out of it. So we select these lines. We define the insertion point that again must match with the insertion point of the 3D block, which is this one. We give a name to that block, like sofa 2D. We say OK, and now when we go back to the furniture styles, we can already assign a 2D representation for the plan view of this sofa. Okay, so now when we see this sofa in 2D, it will use this 2D representation instead. Okay, but again, when we rotate the model, we see the 3D model. Okay, and again, we can create a new style, but in this case, we can use a Grasshopper style. So this will call a Grasshopper definition that they have here, for example, a very simple definition to create a table. But this is not only a furniture, but this is a parametric furniture. Okay, that has a Grasshopper running in the background. So click next. Again, we have different components and the list of parameters that define the shape of this table. So there are some parameters that we will leave that are editable by an object. Okay, and finally click finish, and now we can insert a table here that uses this Grasshopper definition. Let's make sure we're working in the level. So let's place this here, for example. Okay, and we can have also multiple objects that are using the same definition, but the parameters can be different. So in this case, we select the furniture parameters, and here we can see for example, we can change the height of this table as well as the width, okay, or the depth. All right. So from the same definition, you can have multiple objects in order to have different designs. Okay. Now let's take a look at the documentation tools. All right. So let's display this. Let's see the roof as well. When we want to create sections or plan views of this model, up to the current version, the 1.9.5 version, you could create 2D drawings with the section view and the plan view commands. Okay. Now these commands go to a second. Well, they lose importance. Let's say it like this, because as I was saying in the introduction, it's possible to print plan views and section views directly in page layouts in vector output. Okay. But first, let's create a couple of sections first. So first, we'll create a section that is basically an elevation. Okay, so we'll define a length that's important. This, let's call it north. Okay. Let's move to the top viewport because I want to make sure this this section line covers the area of the full model. Okay, just moving the control point. That's possible. We'll insert here another section for this cross section. Let's call it section A, and maybe a third one that crosses along the longitudinally. So we call it section B. Okay. Good. Once the sections are created, now we can open the section manager. Okay, this works in a similar way as the level manager. Let's put that here. And this displays the list of sections we have in the model. We could also create the section from here. This is a shortcut. But now we can select each section and show the model in section according to that to the section list. Okay, so we can switch from one section view to another just by clicking on each one. Okay. And in the same way, we can go to the front or the right view, and let's activate one specific section view that automatically is shown in hidden display mode, so we can appreciate all the hatch patterns. Okay, and we can just change one section or another, activate the clip plane. Okay, or show one section or another, just like these shortcuts in here. And we can do the same in the page layout. For example, if we are preparing the shop drawings of the model, we can click inside a detail viewport and here show specific levels. So we want to show the level -1, while in this model, in this detail viewport, we can show the level 0. Okay, or we can do the same in our layout. For showing a specific elevation, we can show the elevation north or section A or B. Okay, and this is already a drawing ready for printing and for printing in vector output. Okay, so what any change you do in the model will update automatically in here. For example, if we insert here a kind of well, let's create a cone. Okay, just to be used as a kind of column. Let's create it like this, for example. Okay, and if we take a look at the page layout, the cone is already here. So it's a real-time preparation of the layouts with the drawings you want to print. In this case, I didn't mention before, but when we cut through these objects, I mean Rhino geometry, there is the option to assign. Well, let's see this from the ground floor. So we'll move this here. Okay, so just to make sure that it's cutting through the cone, but maybe a little bit forward. Now, it's possible to assign also section attributes through this option here that is available for a Rhino geometry. So we can assign here, for example, a solid hatch pattern. So when we see this section from in the viewports, okay, so we can see already the hatch patterns also applied on Rhino geometry. So basically, you could have the entire model created with Rhino geometry, and just by assigning the section attributes, you could have also the section ready with all the hatch patterns assigned. Okay, let's move on. I would like to show you also another integration of Grasshopper, the one that is already available, which is the option to create the visual objects from Grasshopper definitions. So I run Grasshopper. I can close this document already. And okay, here under the Grasshopper toolbar, there is the option to generate the visual objects. So for example, we can create a wall. So we place a wall component here that requires like a curve for its path and some additional options for changing the parameters. So if we draw a curve, we can reference, this curve with this parameter, assign this curve to the wall path, and now if you want to add more details to that curve, let's change the quality of this display. you can add these wall options. Actually, let's show the full names so we can see all the parameters that, that mean every letter. We assign these wall options to the wall options, and here we can define the same parameters we had available when we were editing the wall parameters in the properties panel. Okay, so we can change, for example, the height just by changing inserting a numeric value in here, or we can change the style, doing right click and setting one style, and picking any of the styles available in the document. Okay, if we want to insert a door in here, so the process is the same. We place a door component that requires a wall. It requires a position, so we could place any point here. So we will use the point on curve command to specify a point on that curve. Okay, and that will be the point to place the door in that wall. Okay, and if we want to add more details to the door, again we have some parameters here, for example, to change the profile. First, we need, of course, to place a door options. And here we can change, for example, the profile of the door using this rectangular profile. That, of course, we need to choose a slider. We can change the values of this slider. And plug this here to control the dimensions of this door profile. Okay, and also there is a component here that is used to pick any curve to be used as a profile for the door. So in this case, we will choose this curve. This connects here, and now we'll use this custom profile to be used for the door style. Okay. So this is already a door that behaves as a door. So if we connect, for example, a slider for the aperture, we can change the aperture of this door. It doesn't matter the shape it has. Now, when we bake these two components, they become visual objects in Rhino. Okay, so we can keep on working with them inside Rhino. Okay, let's get rid of this. I would like to show you a more advanced example just to figure out the possibilities of using VisualARQ. Okay, I will open the recovery file. Doesn't matter. And here there is a definition that creates this dominant structure. So basically, this definition uses VisualARQ slabs, columns, and stairs. Okay, so you can control the parameters from here. Okay, as well as changing the separation of columns. So this is really powerful definition to get multiple designs and changes in real time. Okay, and when we are done with the parameters, this is the component that collects all the geometry, all the visual geometry in this definition. We bake it, and this becomes Rhino VisualARQ elements in Rhino. Okay, a slab, a stair, column. Okay, good. Now, before exporting this to IFC, I would like to show you also one of the new features of the new version, which is the improvements on the table command. Okay, right now it's only possible to list information of visual objects, but in the new version, it will be possible to not only display the information of visual objects, but also to run a geometry. And you will be able to add new parameters using this command here, this option here in the document properties, to add more parameters to the geometry. So here we add a new parameter that could be the price, for example. Okay, and now when we click OK, we can assign this information to VisualARQ objects and Rhino geometry. For example, we can assign now the price that appears here in the properties of those windows, and we can, for example, say specify some price like 30 euros. Okay, or we can specify a price for these other two windows. Okay, like 40 euros, and maybe this one it's 35, whatever. Okay. The idea is that you can add custom parameters, custom properties, and assign information to those objects. And finally, you can list this information in tables. So if we run the table command, we select the openings, well, the table style, in this case, the openings that list information of openings. We select all the openings in this model, and finally insert the table in the drawing. Now we can see in this table that there are some fields that are empty. That means that the reference field in the windows and doors are empty. If we edit this table style, we right-click on the table icon, we can take a look at the property fields. Okay, so we see that if we take a look at that reference, we see that this refers to the tag parameter, which is empty. So let's delete this. Okay, and now we will add a new field, a new property field. We right-click, and that will be the price that we have just added. Okay, so on one hand, this price I want it to be included when I group the information of objects. All right, and on the other hand, here I can define which object types take this parameter. Okay, so for example, since I just assigned the price to windows, here I say that for any window I will take any style, and the parameter that refers to the price will be this one that I have just created. Okay. All right, I click OK, and now I can see the information listed in tables as well. Okay. Great, and this table can be exported to Excel with the table export command. Okay, select table and just export from here. Now let's export the model to IFC and see how it looks like in Revit. Okay, so for this, I mean, all the visual objects will be exported as the object types they are. But in case of Rhino geometry, for example, this cone, here in the properties panel, there is the option to tag this object with specific information for the IFC. So in this case, I will assign the IFC column category to the geometry, and that means that this object will be exported as a column. Okay, so let's export this model. So exporting to IFC is as easy as select Save As, choose the IFC file format in the list, and choose the folder. Also, here there is the options to assign the categories by layer. Okay, if you want. And finally, I save the model in IFC. Okay, so now I will move to Revit. I will open this file. Open. And let's see how it reads the geometry we have just exported. In the meantime, I will just open a new, I will open an IFC file just to show you also that VisualARQ imports IFC files, and also the new features that we have included in the new version, which is the option to also read materials and colors. That was something that wasn't available in the current version. Let's see which goes faster. VisualARQ or Revit. Okay. So we put that in shaded, and we can see that, for example, all these are recognized as walls. Okay. We can change the style. these are recognized as doors. We can move and just keep on working with these elements in Rhino. And also we can work at different levels, okay, in the same way as I showed you before. So let's back to Revit. It's still opening. Yeah, there we go. So we see the model in 3D. And we can, well, select these objects and see that this has been imported as a column. So we can change the type of this column, okay. Or we can select this, and this is recognized as a floor, roof, okay, and so forth. Window, okay, we can change the type. And in this case, we can see that even this is like a non-parametric object, Revit recognizes this as a column. Of course, it can be edited as a native Revit column, because originally Revit doesn't know how this column was created, but still it detects it as a column, and that's useful for the documentation. All right, so this is pretty much what I wanted to show. Quite a lot, I think, quite intensive, and yeah, I will be very pleased to hear from your suggestions or requests if you have any questions.
Thank you, Francesc. Thank you for delivering everything you promised. And thank you for being very demanding when it comes to improving VisualARQ. Yes, we have, you know, a few minutes, so ask away and, you know, take advantage of Francesc while he's here with us at your disposal. So if you have any questions that, you know, technical questions that he can answer you, he would be happy to. And I have a question. So, Francesc, when is do you have a time frame for VisualARQ 2.0?
Not exactly.
Okay.
We expect to have it ready at the beginning of next year.
Perfect.
But we may have like a beta version on before.
Okay,
so
great.
We will give some news about that when
okay.
As soon as possible.
Yeah, great. Okay, I don't see questions. So I think everything was okay. Yes. Again, when the new version will be available, and then I've seen the level mark icon. Is it integrated?
Oh yeah, this is something that I didn't mention before, but this is just another object that is meant to be for annotation elements. So also would be an object that can have like a block for the 2D representation, and also will be available also from to be created from Grasshopper definitions.
Okay.
That basically will be able to be used for elevation marks, for one roses, for any like electricity symbols, anything. Okay, so it's kind of generic symbol for 2D objects.
Cool. And what's the interaction with V-Ray?
It's the same as Rhino. I mean, you can assign materials to visual objects, and no matter if you're using Rhino Render or V-Ray or Flamingo, interaction is the same. Okay. Just take into account that well, you can assign the materials by style. Okay. So, for example, we want to assign V-Ray material to the slabs, so we can assign it directly to the slab. And so all the slabs that are using the same style will take the same material. So here from the attributes, you can assign some specific material, and here in the other you can pick well, this detects the current renderer, okay, and in case of V-Ray, that will detect V-Ray, and you could browse for the V-Ray materials and assign it to the slab. This is an option. The other option is well, directly assign the material from by object. Okay, so you can use here. You're using a V-Ray plugin, so that will be able to be assigned by plugin and assign the V-Ray material as well.
And Federico also asked, did you solve a texturing issue? And it means the ability to texture it like a Rhino geometry.
Yeah, this is an issue we are experiencing because, well, it only happens on VisualARQ blocks in the display viewports. Because, well, this is an existing issue on Rhino blocks, but that also affects visual objects because visual objects are blocks. But when you shot a render, the scale of the texture should look fine. So this is an issue that only affects the display, to the preview of the render. Okay. We are in touch with Manil in order that they can fix that. So they fix that on blocks and also will fix in VisualARQ objects as well.
Thank you. I think this is it, Francesc. If you don't mind, I will take the screen back.
Okay. Thank you. Bye-bye.
Yeah.
Okay. See you soon.
Yeah, no, hold on. I'll wrap it up. Let's see if I can. I don't know if you can see my screen. Yes, you should be able to see my screen. I would like to thank everybody for attending this webinar, and I want to remind everyone to visit the Novedge page at novedge.com, where you can find VisualARQ, Rhino, V-Ray, and all the above. It's a one-stop shop online on demand. Novedge is the best way to buy designer software. And for information on the latest special new releases, join the Novedge network on Facebook, Google+, and Twitter. And don't forget that next week's webinar is about getting the most out of AutoCAD 2017 with Autodesk evangelist Lynn Allen. To rewatch today's webinar or previous ones, check out our Novedge YouTube and Vimeo channels. Our webinar playlist has webinar for every software taste. Thanks again for joining us. Thank you, Francesc, and
thank you, Barbara.
See you next week. Bye-bye.
See you next time. Bye.